Today we're going to look at Unit 11, Section 3. We're going to be talking about surface area and volume. But we're going to be looking at it now in terms of multiple three-dimensional shapes at once. So how do we solve a problem like this? Well, we're going to break this up into solvable parts, manageable pieces. That is a triangular prism on top of a rectangular prism. Let's look at the three-dimensional shape and get a good comprehension of what's happening. All I did was, I took a rectangle and I extended part of it up to that triangular prism. So what I'm going to do for solving surface area is I'm going to find the surface area of the rectangular prism and then the lateral area of that little triangular prism. So surface area, first 6, 6, which means this whole length is 12. 8, 8, 4, 4. Now notice these are all in centimeters. The surface area of a rectangular prism is 2 times the length width plus 2 times the length height plus 2 times the width height. So 2 times the length times the width, 2 times the length times the height, plus 2 times the width, 12, and the height. When I do all of that, I get 352 centimeters squared. Remember, area, centimeters. Sorry, area is the dimension squares. Sorry, the measurement squared, centimeter squared. Now, I'm going to do the lateral area. The reason I'm not doing the surface area, I already took care of the top because I included it in the rectangle, and it doesn't have a bottom. So I'm just doing the area around the circle. Now, I need to do Pythagorean theorem. 6 squared plus 8 squared equals this length. We should know this by now. That would be 10. So the lateral area of a triangular prism is the height times the perimeter. The perimeter of the triangle. 6 plus 8 plus 10. The height is the height of the prism. So 4 times 6 plus 8 plus 10. This gives us 240 centimeters squared. And then I add these two together. And I get a total of 592 centimeters squared as my surface area. Now volume, it's really simple. I'm just doing the volume of my rectangular prism, my volume of my triangular prism. So there's no major real breakthroughs here. It's just volume is length times width times height. So that is 8 times 12 times 4. So our volume of a rectangular prism is 384 centimeters volume cubed. The volume of a triangle prism is big B times H. Big B is the area of the base, which is this, which is a triangle. So the area of the base is 1/2 base times height. Base of the triangle, height of the triangle. Base of the triangle, height of the triangle. So 1/2, 6 times 8. So 1/2, 6 times 8, we get 24 as big B. So the area of the base times the height, and we get 96 centimeters cubed. I add both of these together, and I get 480 centimeters cubed as the volume for this shape. Let's look at another example. How would we solve problems like this? Again, we're going to split into manageable sections. This part, this part, this part, this part. Let's again visualize what it is we're looking at. Here's what it is. Now what's really going on is all I did was I took this shape and I extended the parts up. This went up, this went up, this went up. So I'm really treating this as 4 separate rectangular prisms. Now, surface area is a rather large challenge for a problem like this. So let's figure out all our pieces. If this guy's 10 and both these are congruent, it's going to be 5 and 5. This guy's 10, that part's 5. So this part has to be 5. 5. Notice these are all marked as 5. This whole length has got to be 10. Now, surface area on this problem, it would be a pain. We'd have to find out the individual surface area of all of these shapes. It's going to be it's tedious, but very doable. It's outside the scope of what I'm trying to show you. So we're not going to do surface area with this problem, but we will look at volume. Because volume is very much in the realm of what we're trying to do. Again, this is 5, 5, 5. That whole length's 10. That's 5 because it's congruent there. Which said this is 5, that's 5. This is 5. This is 5. Alright, so the idea, we're going to break this into small shapes. We're going to find the volume of this guy. Then we'll find the volume of this guy. Then this one. And then this one. So the volume of a rectangular prism, length times width times height. So this guy, 5 times 5 times 5. 125. This shape, it's 10 inches by 5 by 5. So we get 250. Oh, and this is volume. These are in inches, so inches cubed. Volume of this shape. This length's 5, so that length's 5, that length's 5, so that whole thing is 10 plus 5. 15. So 15. 5, 5. 375 inches cubed. And the last one is total of 5, 5, 5, 5, 20 inches tall. 5 and 5. So this is 500 inches cubed. So now all I got to do is add them all up, and I get a total volume of 1,250 inches cubed. Now let's look at the next example. How do I solve this? Again, I split up in manageable pieces. I've got a cylinder and a cone on top of it. So if I'm going to do surface area of a cone, well, notice I don't have the bottom. There's no bottom to my cone. So what I'm going to do is I'm just going to find the lateral area of my cone. Remember, lateral area of a cone is pi RL. Remember, L is the slant height, which is already given, and R is the radius. I don't have the radius, but look, this is marked as congruent, so that's 12. 12 squared plus x squared equals 13 squared. There's another one you should know by now. We would get 5 for the radius. So the lateral area of the cone, pi times 5 times 13, and so I get 65 pi for the lateral area. Notice this is in feet, area, feet squared. Now, I'm going to again do the lateral area. I'm going to find the lateral area of my cone. my lateral area of my cylinder. The area of the base, I'm going to find shortly. It doesn't have a top, so that's why I'm not doing surface area. I'm doing lateral area, and then I'm going to do the base individually. Lateral area of a cylinder was 2 pi r times h. Well, radius is 5, height is 12. 2 pi times 5 times 12, and we get a lateral area of 120 pi feet squared. Now I'm going to find the area of the base. Well, this is just a circle with a radius of 5. So I'm going to find the area of a circle, which we know an area of a circle is pi r squared. So that's pi times 5 squared, that's 25 pi. Add all of these up, and I get 210 pi inches squared. Feet squared as my surface area. Let's do volume now. So I already solved these. This is 12, and that's 5. Now I don't need to do anything funky here, because it's just, hey, volume of a cone, volume of a cylinder, and I'll be okay. Volume of a cone is 1/3 pi r squared times the height. So the radius is 5, the height is 12. So 1/3 pi times the radius times the height. And here I get 100 pi. This is feet, volume, feet cubed. The cylinder, volume of a cylinder is pi r squared times the height. Same idea. So pi, 5 squared times 12, I get 300 pi. And again, volume, feet cubed. So now I've got the volume of my cone, volume of my cylinder, add them together, 400 pi feet cubed. We'll do more examples in the practice. I'll see you next class.